In this session, we are going to understand the relationship between big data and cognitive computing. A cognitive computing environment definitely requires sufficient amount of data to discover patterns or anomalies within the data. Many situations we really need a large data volume, large data set. Within a cognitive system, it is also very important to have sufficient data that the results of that analytics are trustworthy and consistent. I am getting the analytics done, but are they trustworthy? Are they consistent? Is a very important point. When you have large amount of data, it naturally helps in generating better insights. To accomplish the goal of getting proper insights from the data, a cognitive system include both structured and unstructured data. I cannot just say that the cognitive system can handle only the structured data. It has to also have a mix of structured and unstructured data. Structured data, as you know, can be relational database format, and that is easy for system to handle. On the other side, unstructured data can be in the form of even written material, it can be video, it can be images, and it is mostly designed for human consumption and interpretation. We are going to discuss these perspectives also, and that will help us in understanding the connect between big data and cognitive computing. And dealing with human generated data is actually very challenging. It is technically and financially difficult to manage a lot of data, leave alone or let alone the petabytes of data. If it is large volume of data, it is definitely difficult to manage. In the past, most of the organizations, what they could do is to capture the samples of the data, and they believed that the right data was sampled. That's all. But there were limitations. How much analysis could be done when major data elements might be missing? This is a very right question to be asked. I'm taking sample, but you are missing a large volume of data. So, in addition to this, the scope of the data needed to gain deeper understanding of business and technical issues has expanded dramatically. So, companies definitely want to look into the future, and they want to predict what will happen next, and then they also want to understand the best actions to be taken. Without big data techniques, cognitive computing would not be nearly useful as well. This is a very important line of conclusion we are drawing here. Without big data techniques, cognitive computing may not really serve the purpose. So we have to go into the big data to get cognitive computing better. Let's define the big data. Big data requires the capability to manage real huge amount of structured as well as unstructured data at an appropriate speed and within the right time frame to allow insightful analysis. Here, two things are to be observed. One is structured and unstructured data is pulled in, and the second thing is at appropriate speed within right time frame. Both are brought in here. So this is a very important aspect that someone should look into. Big data typically consists data from variety of related and unrelated sources that can definitely make it complex. So this can result in huge data set that may be difficult to manage as well as to analyze. The architectural underpinnings of the big data environments have to be designed in such a way that they are highly distributed, and it should enable the data to be managed and processed quickly. Not only this, it has also to be managed efficiently. This requires a highly abstracted and open application programming interfaces, we call it APIs, that provide capability for a variety of data sources to be ingested, integrated, and evaluated. Big data solutions definitely require a sophisticated infrastructure which include security, physical infrastructure, and analytics tool. It is not easy to handle a huge volume of data without this kind of support. You need security, you need physical infrastructure, you need analytical tools, without which it's nearly impossible for somebody to handle such a large volume of data. There are four V's which are connected to big data, which we are aware of. First one is volume, second one is velocity, third one is variety, and finally veracity. Volume, we have got a large volume of data to be handled. It's a huge volume of data. Terabytes to exabytes of existing data to process is not an easy task. And then velocity. Data in motion is what we are talking about. We have to look into the streaming data with literally milliseconds to seconds to respond. And data in many forms is called as variety. It can be structured, it can be unstructured, it can be text, multimedia, anything. We have to handle them. And data in doubt is called veracity. there is a lot of uncertainty which can be connected due to inconsistency, incompleteness, ambiguity, latency, deception, and model approximations. And we have to handle this as well. So these four V's are very important to be looked into: volume, velocity, variety, and veracity. Now we have defined big data, we have connected four V's to it, and the next step is to understand the architectural foundation for the big data. It is very important to understand the components of the big data technology stack. We have presented it in front of you as a picture, and we are going to explain and understand each and every components of it very nicely. It's going to be very easy to understand. First comes the physical foundation for the big data. You need to understand a very important point. You should understand the point that the big data and cognitive computing systems require a very strong foundation of systems, and it should not take time delay at all. It should not conceive time delay at all. There should not be any latency. This physical infrastructure include the networks, the hardware, the cloud services, and whatnot. Everything connected to the systems and hardware side coming into picture. The underlying physical environment of a big data infrastructure need to be definitely parallelized and redundant. I repeat this point, it has to be redundant. And coming to the networking aspect of it, it must be designed in such a way that the data can move literally fast. We have seen 1B which says that data in motion. So the networking will support you to handle the data in motion. Likewise, storage must be implemented and configured so that it can move or connect to information at the right speed as required, because most of the times delay is to be avoided. We all expect real-time performance. So remember it. The physical foundation for the big data is so very important, and this needs a lot of attention. And coming to the security infrastructure, that's the next layer. Security has to be definitely built into cognitive applications. No compromise should go in here. There are situations when data comes from real devices, which can be like the sensors or the medical devices. Additional security is paramount. So, the security infrastructure must definitely ensure security when the data is in motion and when the data is distributed. Both the aspects I'm telling you, the security infrastructure must definitely ensure security when the data is in motion, also when the data is distributed. Often the data comes from variety of sources and it is used for different purposes than originally intended. So for an instance, the patient information moved to a big data application might not have the right level of protection for private patient data. This is an annoying thing and we should really look into it. So the security infrastructure needs to have the capability which can definitely ensure that the data such as the social security number or Aadhaar number in our country should be taken care of, and it should be hidden properly. They are all personal data and they are highly confidential data which should be hidden. The techniques which can be like the tokenization can be deployed so that unauthorized users cannot access sensitive data. So the security infrastructure literally needs a lot of attention to be paid, and it is to be given without fail. Without which the cognitive system may leak data which is not correct. And operational databases is the next aspect, next very important layer we need to look into. What makes big data complicated? Very simple. It is the requirement to use and integrate many different type of databases and data structures. We have a strong requirement where we are requiring to use and integrate multiple different types of data as well as data structures. Although a lot of data that will be important to a cognitive system will be unstructured, these data may also need to be stored and managed in structural SQL databases. Please reiterate this point when you're looking into it. These data may also need to be stored and managed in structural SQL databases. For an instance, there might be a travel planning application which could require structural data about the hotel room availability hosted in an SQL database. Similarly, in a healthcare application, there could be a requirement where we may have to gain access to databases of drugs implemented in SQL. So, you need to understand the role of both structured and unstructured data when they come together in such environment. It is very, very important to understand the role, and you have to act accordingly to handle the structured and unstructured data. We have seen the security infrastructure, we have seen the operational databases. Now we getting into the next level where the data services and tools are to be discussed. A distributed file system is needed to manage the decomposition of the structured and unstructured data streams. A distributed file system is often a mandatory requirement for taking through the complex data analytics. When the data comes from variety of sources, it becomes complex, and in that situation, you can go with distributed file system. Serialized services are also required to support persistent data storage as well as supporting RPC, which is remote procedure call. The coordination services are definitely essential for building an application that leverages highly distributed data. We know ETL, extract, transform, and load. ETL services are required to both load and convert the structured and unstructured data to support Hadoop. We'll talk about it a little later. And workflow services are the techniques for synchronizing processing elements across the big data environment. It is across. So we need all this to be looked in as well. Now, in this session, we have clearly understood the connect between the big data and cognitive systems. We have also seen the architectural foundation for big data. Next session, we'll learn more deeper with respect to Hadoop as well, and it's going to be interesting. Thank you.